Good morning, Programming 12. We are going to be taking a look at expanding the Tic-Tac-Toe client now to be networked. Last video, we took a look at making the server into a Tic-Tac-Toe server. Now we're going to do the client. And then I'll try running them and see if I screwed up. uh, Learning online. Isn't it great? Don't you just love it? Isn't it the best? It's actually not so bad, right? There's some good stuff to it, but it's a bit awkward sometimes. Anyways, here we go, folks. I'm going to be taking this client network. This is the client from our chat program we wrote. And I'm going to be cannibalizing it, or salvaging pieces. That sounds more exciting than copying and pasting. But basically, I'm going to copy and paste the guts of the network stuff from here and put it into the Tic-Tac-Toe program. I've saved a second copy of this, by the way. So there's two sketches. There's the client and there is the server. Two separate sketches, as you saw. This is the server here. This is going to be the client. And I'm starting with the base code from our Tic-Tac-Toe program we wrote 2 lessons ago. And this is available on GitHub. If you go to the class notebook, you can find the link for that. Okay, so here we go. The client is pretty much just, same kind of idea. You're going to copy and paste the client stuff. So I'm going to get the library, importing statement, and I'm going to put a comment up here just to remind me that this is the client and that we're going to use ones or O's to play the game. The server used 2's. I just double checked that actually. Yes, it sends X's or 2's. So... yeah, do we need apostrophes in here? I mean, that kind of needs one. I don't know. I'm not too familiar. All you masters of the English language, let me know in the discussion channel what's the proper use of the apostrophe there. Anyways, that's the first thing. We do need the client object, which is going to be our gateway to connecting and communicating with the server. We're not going to use the outgoing and incoming declared as up here because they don't have to be persistent. We're going to generate that string when we send the message, but we don't need to keep it afterwards. We're also going to be receiving messages for sure, but we don't need to keep them after we've recorded the move in the grid. So we don't need to declare them up here. We'll have them later. We also don't need a valid string really because we're not typing things, we're just sending coordinates. So the next thing is we are going to want to grab this line of code here. This is what allows us to connect to the server. And we're going to use, again, this address here. This is the localhost, as it's called, address, or yourself, basically, your internal IP. If you want to just say, hey, I want to talk to myself. And, in social distancing times, that's a pretty common pursuit I've experienced. Just talking to yourself. So this is how you do it in network terms. You do make sure that you are using the same port number as the other as your other program, as your server. Just confirm that you have the same port there. All right. Scrolling down, that's sort of our initialization, the setup. Now we have to do both the sending of receiving, I guess, goes in draw, the listening, and the sending is going to go in mouse released. So I'll go into the draw function first, and we'll do that listening. It's this bit of code right here. So I'm going to copy that over, and I'm going to put it at the bottom of the draw function. And I'm just going to expand this a bit because you probably can't see it too well. Because I can't see it too well, so what chance do you have? So here we go. I'm going to put in the receiving messages component, which of course a message is going to represent a move that your opponent took. So this string isn't defined anymore, so I'm going to just define it here. Again, we don't need to keep this string after we've recorded the move in the grid, so no point in declaring it at the top. Let's just declare it right here, and then it'll get reinitialized every time we receive a message. So yeah, if we receive a message, we're going to read the message, and then we got to do the same kind of thing we did in the server. I'll just bring that up to remind you what that looked like. If you understood what happened in the server, then this is going to be no different. In the server, we did this whole, read it in and then, get the row coordinate and the column coordinate using this substring function, which basically pulls out a smaller string out of the larger string. So here's our larger string. Let's pull out the move here. So that's good. And I'm going to just steal that. Just going to copy and paste it right out of this server. This is the same code, really. So that's that. And then I think that's everything we need to do. I think that's the... Oh, wait. No, there's one change. So that isn't going to be a 1 anymore, is it? That's got to be a 2. Our opponent's playing 2s, so we need to record that as a 2 in our grid. Okay, now we're good to go. I want to hide that again, and I want to take a look at the client, because then we have to do the writing. My windows are falling apart. Yeah, so here's our writing code. It's basically just write this outgoing stuff here. But we're not going to write outgoing itself. We are going to do something a little bit different. We're going to just write the coordinates that we clicked on, this stuff. So in our client, we're going to record a 1. So make sure you make that change. Otherwise, you're only making moves with X's. So when we make a move, we're going to record it in our local grid to say, oh, we made an O. And then we need to send that information over the internets. So I'm going to put in a myClient.write. It's not going to be outgoing, though. It's going to be row plus a comma plus, no underscore, the column. So when we click, we'll get the coordinates out of the mouse, like the row and column numbers out of the coordinates. And then if it was a valid move, we'll giddy up and assign the value for an O in our local grid. And then we'll send a message to be like, psst, server, we made a move. It's this one here. And then the server can receive it. Okay, it's very exciting. I'm going to test it out, and this is where things will probably go wrong, and it'll be an awkward pause. I once had a professor at university, at UBC, who would make us give him a round of applause if his code ever worked in a live demonstration, because it's not easy to do. So here's my client, here's my server. You always have to run your server first, so let's do it. Bloop. There it is. And here's my client. Bloop. Okay, I should probably differentiate them a little bit because I'm going to get lost. Okay, I'm so nervous. I'm gonna press a thing. You gotta see. Bloop. Oh, it worked. So I pressed X, and that X showed up over here. I'm going to press over here. Oh! I didn't expect it to be a black circle. But I'm into it. This kind of got some sort of, I don't know my art terminology, but no, I'm not going to try. Here, I'll go make a move. Okay, I shouldn't have moved there. That's clearly the wrong move to make if you're much of a player of the tic-tac-toe. Go here. Where are you going to go? Oh, you got to go here now, which means I got to go here, which means I got to go here. Oh, no! I can't block it. Oh my gosh, I'll try to stop him. And then nothing actually happens. There's no victory. I could keep playing if I want to. Notice I can't overwrite the pieces though. Like if I try to do another move on top, it doesn't work. That's great because we've put in this line of code here. I only can make a move if it's already no pieces available there. Let's just run this again. I'll show you some problems that we're going to solve now. Some problems we're going to solve, and I'd like you to implement these solutions. We can do a video on the answers to these if they're troubling you at all. Check this craziness out. You ever played tic-tac-toe against someone who's obviously cheating? I know, you might be like, no? Because, like, how do you cheat? My children try to cheat. They're like, I'm going twice. And my kids would like this version, because watch this. X, or O, apparently. O, O. Oh no! There's no turn taking that is required. So something I'd like you to build in is something where you decide arbitrarily which is going to go first, server or client. And then I'd like you to make it so that when it's that, say we say server goes first, X's go first. The client can't make a move until the server makes its move. It's just sitting there. There should be some kind of like signal. Maybe the background is a different color or something, or there's a sign, a picture of a lock. I don't know what you want to do. Some indication that you can't make a move. Until the server makes a move. I guess this is a server over here actually. Once the server makes a move, then the server's locked and should show the same sort of indicator, and your client gets unlocked and then can make its move. So basically enforcing turn taking. That's what I'd like you to do today. And if you can make that happen for next class, that's fantastic. Please feel free to throw me some questions. I wanted to give you a task that isn't too hard because it's really hard for me to debug code over this distance learning thing. But I know this is a task that is going to help you dig into this code. So if you've been kind of listening along, but you don't feel like you fully understand it all in detail, then making changes like this will kind of help you, guide you to explore this code in a little bit more detail. Okay, so feel free to ask questions about that in the I almost said in the Discord, in the Teams channel. Teams is like a boring Discord, really. So yeah, sure, that's fine. And I look forward to seeing how your projects turn out. Okay, thanks everybody. Have a nice day.